we want to use the load impedance, so the power dissipated in it is a maximum. And then we need to determine how much power that is. So you may recall from circuits 1 that when we did circuits 1, we said we had maximum power transfer when R load equaled R Thevenin. So it's very similar here. We're going to have maximum power transfer when Z load equals Z Thevenin conjugate. So first we need to find Z Thevenin. So we're going to draw the circuit with the load removed and changing voltage sources to short circuits and current sources to open circuits. And we'll find the impedance of what we have left. So we want to have the impedance as seen from the point of view of the load, which would be right here. So we can see that what we have is an inductor and resistor in parallel, and that in series with the capacitor. And so Z Thevenin will equal minus J4 plus J2 in parallel with 4, or minus J4 plus J2 times 4 over J2 plus 4 is minus J4 plus J8 over J2 plus 4, J2 minus 4, J2 minus 4. My laziness factor is what's actually going to take more energy to open up the calculator and do this, or do it on my own. So J8 times J2 is minus 16, minus J32 over J2 times J2. This is nope, this should have been minus J2 plus 4, because to multiply by the conjugate, so it's plus 16 plus J32, and then that would be 4 plus 16 minus J4 plus it would have been easier to use a calculator. J32 plus 16 over 20. So that is 0.8. Let's see. 16 plus J32 is 4 plus 16 is 20. 19 divided by 20. So 0.8 minus J2.4. So that is Z Thevenin. So we will have the maximum power transfer when Z load equals Z Thevenin conjugate, or when Z load equals 0.8 plus J2.4. Now, what if your circuit looked slightly different than this? What would you do? Well, you'd do the same basic idea. So, like, let's say, what if your circuit looked like the piece of paper my cat is sitting on? Maybe it is just causing problems today. Can I have this kitty? Okay, so let's say we had a circuit that looked like this. and that was our circuit, and we needed to find Z load. Okay, well, how would that be any different? It really wouldn't. So what you would want to do is find Z Thevenin for this part over here, and so when you would do that, this circuit would look like this. And so you would have, say this is R1, R2, and this would be minus J over omega C. And so you would have, those would be in parallel, so it would be R1 times R2 minus J over omega C over R1 plus R2 minus J over omega C, and that would equal Z Thevenin, and then you would just get the complex conjugate of that. Okay, so we discovered that for maximum power transfer we would want Z load to be 0.8 plus J 2.4. The second part of the problem is how much power would that be? So what we need to do to figure out the power, we know that when we have maximum power, that maximum power is going to be the magnitude of the source voltage over the real resistance of our load. And so we need to get the magnitude of the source voltage. So to get the magnitude of the source voltage, we're going to look at the open circuit. So we would look at our circuit with Z load removed. So we have So here is our circuit. This was minus J4. This is J2. This was 4 ohms. This is 20 angle 0. And to find the voltage here, we can do voltage division. Yeah, I gotta do voltage division. I am. Okay, because right here in this circuit, since it's an open circuit, this is not doing anything, and so our voltage is going to be the same as the voltage across that. So we can just do voltage division. So V open circuit equals 20 times the impedance of this bottom part, which is J2, over the sum of the impedances, which is 4 plus J2. And that would be J40 over 4 plus J2. And that would be I get that it is 4 plus J8, and then, which if I wanted to have that in polar, I could have it in polar. Not going to. Okay, and so I do, however, well, I have to have the magnitude of it, so the magnitude of that is the square root of 16 plus 64. Which is 8.94. And so now I can say that P max equals 1/8 Vs squared over RL. So it would be 1/8 times 8.94 squared over just the resistive part. And the resistive part, if I look at Z load, the resistive part was 0.8. So this is 12.5 watts. Okay, so, and that answers this question. Let's say the question had not said to find, it just says how much power will that be. Let's say the question asked for complex power. To answer that, I'm just going to ask you to think about it and to think about what are we doing when we are finding the impedance that would give us the maximum power. What are we doing when we do that, and how can that help us answer the question if we were trying to find the complex power? So, I mean, there's lots of ways you can do it, but if you think about it, you might be able to come up with a little easier way to do it. All right.